Welcome back in my session of electromagnetic field. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department in IARE Hyderabad. Today I will tell about some important definitions and terminology of electrostatic field. Already we have discussed the electrostatic field. Today it is some important definitions and terminology. So, for today's lecture, we will start the basic definitions of dot product in vector analysis. What is dot product and what is cross product? So the dot product is also called the scalar product. It is a product or multiplication of two vectors is a number obtained by performing a specific operation on vector components. So what is this? We will multiply two vector components and we will get a number or a scalar quantity. The dot product has meaning only for pairs of vectors having the same number of dimensions. So we can also we can consider two vectors A and B and the angle between them is theta. And for the sake of simplicity, we are taking here two-dimensional. So, if we see the output, we can see this is the one. So, you can see this is the A and B and we are getting A dot B cos theta. And theta is nothing but the angle between A and B. So A is a vector quantity, B is a vector quantity, but AB cos theta is a scalar quantity. And here we have taken for a two-dimensional space. For example, if one vector is 5i plus 2j and B vector is 3i plus 4j, and if we do A dot B, we will get 10 plus 8, 18, and this is a scalar quantity. And how we can get the cos theta? From the equation only we can get the value of the cos theta. Cos theta is equal to A B by A B. What does it means? A dot B divided by A into B, or magnitude of A and magnitude of B. For the same problem, we can get the magnitude of A is 25 plus 4 and magnitude is B is 9 plus 16. So, what is the value? A dot B is equal to 18, already we got here, divided by root 29 into root 25, or we can write also 5. So, this is the cos theta, but here there is no dimension. So, what is scalar? The dot product is a scalar product. Now, we will discuss the cross product. So, just unlike the dot product, cross product is a multiplication of two vectors and the result is in the vector domain. So, according to the definition, the cross product is defined as a vector C that is perpendicular or orthogonal to both A and B, and the direction, we will get the direction of the resultant by the right hand screw rule, and the magnitude equal to the area of the parallelogram at that vector span. So, you can see the cross product we will write by A cross B. And as I told earlier, it always follows the right hand rule. Right hand rule means if A is a vector and B is a vector, the thumb will show the direction of the thumb of the right hand. if A is a vector and B is a vector, the thumb will show the direction of the resultant or result vector. So you can see, if we are calculating the previous expression A cross B, so if you can see from here, this is our A, this is our A, and this is our B. So C should be, if it is A cross B means A to B. So the thumb, this one, the thumb will show the direction of the vector, and cross product is a anti-commutative. You can see the word anti-commutative. What is the meaning? A cross B is not equal to B cross A. A cross B is equal to minus of B cross A. So this is the important point of here. So you can see there are two thumbs are here. One is A, one is B. A cross B means from A to B, A to B, and the thumb will showing the upward direction. If we do the B cross A means opposite direction. So thumb is showing the downward direction. So we can understood the cross product is a vector product, and the direction we can get from the right hand screw rule or right hand rule. Next important definition is define point charge. What is point charge and why we need the point charge? Now, a charge with the smallest dimension of any body compared to other charges is called a point charge. Point charge is a fictitious thing, a charge with the smallest dimension. Any electrical molecule, if we break it, we can get some charges. Either it will be positively charged or it will be negatively charged. Positively charged means number of electrons is less than the number of protons, and negatively charged means number of electrons in an atom is greater than the number of protons in the nucleus. And now, if a charge with the smallest dimension, if there is a charged particle and there are the different amount of charges in different particle, which has the minimum value, that is only known as the point charge. So point charge is known as the smallest dimension body. As I told earlier also, a point charge is a hypothetical charge, or it is a fictitious quantity. It is located at a single point of space. Single point of space means in the space there are two dimension or three dimension. Anything in the space is a three dimensional things, x, y, z. So, but if anything is only at a point which is basically dimensionless, we will tell it, or it is at a single dimension, we call it as a single dimensional point charge. Its size can be characterized by the length scale known as the electron radius. As this is the charge, so it will be calculated by using the length scale of the electron radius. So you can see here two figures. One is the positively charged, another one is the negatively charged. And you can see the lines of forces are going out from the positively charged. This is the this is diverging in nature, and this is converging in nature. So this is the thing of the point charge. Now we will discuss the another important definition. permittivity. Permittivity is a very important thing, and it is written by epsilon. Sometimes it is written by epsilon. And what is permittivity? The ability of a substance or a medium to store electrical energy in an electrical field is known as the permittivity of the medium. So permittivity means the ability of the medium to store the electrical energy. Permittivity is basically two types. One is called the absolute permittivity, which is basically the permittivity of vacuum or air, and it is written as epsilon 0, and we write it 8.854 into 10 to the power minus 12. So absolute permittivity means the permittivity of the vacuum or air. Then what is relative permittivity? Relative permittivity is this is the ratio of the original permittivity divided by the absolute permittivity, and we write the relative permittivity by epsilon r. The permittivity of any medium, the permittivity of the any medium is written as epsilon is equal to epsilon naught epsilon r. So this is the permittivity of any medium. It is two types: absolute permittivity, relative permittivity. Absolute permittivity is equal to the epsilon 0 is equal to 8.854 into 10 to the power minus 12. Relative permittivity is the ratio of the true permittivity with respect to the absolute permittivity. Like epsilon r2, what does it means? The permittivity of the medium is the 2 times of the absolute permittivity. If epsilon r is equal to 2 for any medium, then what will be the permittivity of that medium? It should be 2 into epsilon 0. So this is the relation between the permittivity of a medium to the relative permittivity. Now we will going to the next definition. What is the electric field intensity? Electric field intensity is a very important term in the case of the electrical engineering. So what is field intensity? The electric field intensity at a point is the force experienced by a unit positive charge placed at that point. Or we can tell the work done, the force experienced by a unit positive charge to bring it from the infinity to any electric field. So the electric density, we will write the electric field by the letter E, and actually it is E. It is a vector quantity. The amount of work done is required to bring a unit positive charge from infinity to 1 point, or we can tell the electric field intensity at a point is the force experienced by a unit positive charge placed at the point. Units of electrical potential per distance in SI unit is the volts per meter. The unit is volt per meter. So it is a very important thing in the electric field, and the total electrical engineering depends on this unit or this definition. Then with electric field intensity, another term okay, I will go in the last one once. And another definition of electric field intensity is Q by 4 pi epsilon 0 r square AR. What does it means? It means if Q is a charge, to bring the Q charge in a point of r distance, the amount of force required is known as the field intensity to bring a point unit positive charge to one point to the radius r is known as the field intensity. And what is air? Air is nothing but the unit vector, and it gives the direction of the vector. Air is equal to radius r, the distance of the point from where we are bringing, divided by r. So we got the field intensity. Field intensity definition is derived from the Coulomb's law. So what is Coulomb's law? Coulomb's law is A is equal to Q1 by Q2 by 4 pi epsilon 0 r square AR. As we are bringing the positive charge, so Q2 is equal to 1, and if we put the value 1 here, we will get Q1. If Q2 is equal to 1, we will get Q1 by 4 pi epsilon 0 r square AR, and this is nothing but the electric field intensity. So what is the another definition of electric field intensity? We can tell another unit is the Newton per Coulomb, A by Q1. The unit of force is Newton and Q is Coulomb. So another unit is force per Coulomb. Next definition. Define electric field or electric flux density. What is the meaning of electric flux density? The electric flux density can be defined as the electric flux per unit area. And according to the Gauss law, number of electric flux equals to charge enclosed. According to the Gauss law, electric flux is equal to charge enclosed, and this is the Gauss law. So, the electric flux density can be defined as the electric flux or electric field lines of field per unit area. So, we can write D is equal to psi by S, where psi is the total flux and S is the surface area. Generally, as our Mother Earth or our environment is a sphere, so we generally take the surface area as the sphere. So what is the surface area of a sphere? A is equal to, or we can write S is equal to 4 pi r square. So what is D? According to the Gauss law, psi is equal to Q. So Q by 4 pi r square. And from the previous slide, we got that E, the field intensity, is equal to Q by 4 pi epsilon naught r square. And we got the relation D is equal to epsilon 0 for E, for the for the flux density in air. If we go for the any other medium except air, or we can say the any other medium, we can write D is equal to epsilon into E. Next, name the types of the charge distribution. Already we came to know that charge is the point charge. Except point charge, we want to distribute the charge. So there are the three types of charges there. First one is the line charge. Second one is the surface charge, and third one is the volume charge. So, what is line charge? Charge along a line. If the charge is along a line, we can tell it the surface charge, and line charge is equal to rho L into L, where rho L is the line charge density. Similarly, for the surface charge means the charge in on any surface, the charge in any xy surface. So there we can get the surface charge is equal to rho s into s, where rho s into s means rho s is equal to surface charge density. If we think about the volume, the charge along a volume of any surface, any medium or anything, that is called the volume charge, and volume charge QV is equal to rho V into V, where rho V is equal to volume charge density. So, charge density is three types: QL, QS and QV. Now we will discuss about the Stokes Theorem. What is Stokes Theorem? The Stokes Theorem states that the surface integral of the curl of a function over a surface bounded by a closed surface is equal to the line integral of the particular vector function around the surface. So this is a big statement. In easy form, the Stokes Theorem says the surface integral of any function is equal to the volume integral of divergence of same. So what does it mean? It means, say we have a function x into dl. So x into dl means this is a line integral. We can change it as the, or we can better, we have a line integral x into dv. We can change it grad x into ds. So volume integral can be changed into the surface integral. Volume integral can be changed as the surface integral. Stokes theorem can be used to turn the surface integral through a vector field into the line integral. Again, similarly, we can change the line integral to surface integral or surface integral to the volume integral. Next important definition of this chapter is Maxwell's first equation. So Maxwell's first equation is basically derivation from the Gauss law. It has two parts. One is point form, another one is the integral form. Point from the Gauss law we know Q is equal to integration of d dot ds equal to integration of grad dot d dv. So from the Gauss law we can write Q is equal to rho v dv. Q is equal to rho v dv. Already we have discussed the volume charge integral. So any charge will be in the volume. So Q is equal to rho v into dv. And from here Gauss law we got rho d dot ds, and we are using the Stokes theorem here. Stokes theorem. So surface integral has been changed into the volume integral. So we can get that rho v dv is equal to grad dot d dv. So is equal to v grad dot d dv. So if we compare these two equations, we got grad dot d is equal to rho v, and also in the integral form we got q is equal to d dot ds is equal to grad dot d into dv. Next, resolve the unit vector in terms of the distance vector. A unit vector is a vector that has a magnitude of 1 unit. Any vector can become a unit vector by dividing it by its magnitude as follows. A is equal to A vector by A. So in a three-dimensional, we have a vector I Generally we write any vector along x-axis, we write it by I. Any vector along y-axis we write by j, and any vector along k-axis is written by k. In EMF we also wrote x is a x, j is a y, and k is a z vector. Let's take an example. A is equal to 5i plus 2j plus 7k. So what will be its unit vector? Unit vector will be, first we have to calculate the mod A, and the value is 5 square plus 2 square plus 7 square, 25 plus 4 plus 49. And then what will be the A vector? Vector A, that is the total vector, divided by mod of vector A. Next question. So we will classify the coordinate system. Coordinate system we use from our very childhood, and we know coordinate system is 3 types. Basically 2 types. One is the orthogonal, another one is the non-orthogonal. Orthogonal means the 3 axes are at the 90-degree apart, and non-orthogonal means the axes are not 90-degree apart. We can divide the orthogonal into the 3 parts: Cartesian or rectangular, which is the basic x, y, z; cylindrical, rho, phi, and z; and spherical, r, theta, phi. So we have this type of coordinate system in our regular life. So coordinate and non-orthogonal means the axes are not 90-degree apart. Basically, we do not use the non-orthogonal coordinate system for our regular. We generally use the Cartesian and rectangular. It has 3 axes: x, y, z. For the cylinder, it has also looks like this. This is our z. This is our rho, that is the radius. And one is this angle, and the angle is phi. For the spherical, means it is a circular in nature. So one is this radius is r. Angle across this is written as theta. That is actually the height. Another one is this angle, and this angle is the phi. So this is the 3 types of coordinate system. Next. Convert the Cartesian coordinate into the cylindrical coordinate. So you can see, as I told earlier, this is the xyz, it is the r phi z, or we can rho it rho phi z, and we get the relation r is equal to root of x square plus y square, phi is equal to tan inverse y by x, z equals to z. How we can get? So first z, if we are thinking this is a cylinder, this is basically a cylinder here. So height is same. So z equals to z. What about the radius? Radius is the surface of the cylinder, and it has 2 axes, x and y. If this is the phi angle, x is equal to r cos phi, we got it here, and y is equal to r sin phi, and r is equal to root of x square plus y square. What is angle phi? Phi means if we divide the y by x, we will get tan phi is equal to tan inverse y by x. Y by x is equal to r sin phi by r cos phi equals to tan phi. So phi is equal to tan inverse by z. So this is basically, so if we want to do the Cartesian to cylindrical, Cartesian, this is the Cartesian to cylindrical, and this is the cylindrical to Cartesian conversion. Next, if we calculate convert the Cartesian to the spherical. Similarly, we can get that there are the three components r, theta, phi, as I told before also. We get rho is equal to square root of x square, it should be square root of x square plus y square plus z square. Theta is equal to tan inverse y by z. X and phi is equal to tan inverse square root of x square plus y square by z. So next, this is the very basic questions. State the Coulomb's law. Coulomb's law states that magnitude of the electrostatic force of attraction or repulsion between two electric charge is directly proportional to the and the inverse square relation. This is an inverse square relationship, and that's why Coulomb's law is known as the inverse square law. So Coulomb's law can determine the force is attractive if the charges are in opposite direction. The forces are proportional to the charges. F is directly proportional to Q1 and Q2, and they are inversely proportional to the distance between them. So force is directly proportional, and K is the proportionality constant, and the value of K is equal to 1 by 4 pi epsilon 0. Next, define potential difference with its relevant expression. The electrical potential difference between 2 points in an electric circuit is the work done to move a unit positive charge from one point to another. So the work done V is equal to W by Q, where W is the work done. The unit of the potential is volt, and we will denote it by the term V. So this is a very common difference, the work done to bring one charge from one point to another point. Next, define the potential difference and write the relevant expression. So this is over. Extract the Laplace equation and define the Laplace operator. Laplace equation states that the Laplace of the electric potential field is 0 in a surface-free, source-free origin. What does it mean? Laplace equation states that the Laplacian of the electric potential field. So this is the electric potential field V, and grad square V is equal to 0. Grad square V is equal to 0, where grad is equal to del by del x plus del by del y plus del by del z. And grad square means del square by del x square plus del square plus del y square by del square plus del z square equals to 0. Grad square V equals to 0, and if grad square V is not equal to 0, this is known as the Poisson's equation. This is known as the Poisson's equation. So equation is basically two types. One is the grad square V. So this is a second order differential equation that yields the scalar electric field, which is an indication of the time varying electric field. Next definition. Express the electric field intensity on a surface charge. We already got for a surface E is equal to Q by 4 pi r square, 4 pi epsilon r square. And already we also know dq is equal to rho s by ds, where rho s is known as the surface charge density. So what is the value of Q? E is equal to rho s ds by 4 pi epsilon r square, or this is basically dE. So E is a double integration rho is ds by 4 pi epsilon r square. As this is a surface area, it is always a two-dimensional things. So it has one x-axis and y-axis. So that's why this is a double integration. Then express the volume of the field intensity on volume charge. Similarly, Q is equal to 4 pi epsilon r square, dq is equal to rho v dv. So dE is equal to rho v dv by 4 pi epsilon r square. So E is equal to, this is a volume, so this is a triple integration rho v dv by 4 pi epsilon r square. And so today we have discussed about the first one, some important definitions and terminology. And here the triple integration means x is equal to 0 to x, y is equal to 0 to y, z equals to 0 to z. So in this topic, we have discussed some important definition. First one is the dot product and cross product. This is a very, very important definition for the vector algebra. Then we have discussed about the point form. We have discussed about the different types of integrations with different types of charge, like the line charge, volume charge, surface charge. Then we have discussed about the different types of coordinate system. What are the coordinate system? Orthogonal, non-orthogonal. Orthogonal is again three types. One is the spherical, Cartesian and cylindrical. Then we have discussed about the conversion of one to another types of conversion. One to another type of coordinate system. Then we have discussed about the field intensity, potential difference, then electric field intensity on volume charge, electric field intensity about the surface charge. So this is the today's class, and thank you. So up to this, next one is thank you, and thank you all.
Like, share and subscribe. Hit the bell icon for more updates.